Sir, me.
Okay. Yeah, you and Mrs. Sarani as well. Anyone else? Has anyone tried solving the matrix method of OLS using R yet? Okay, all right. Uh, how many of you have performed any regression exercise on R? Okay, all right, Bhushan.
Sir, we had done it last semester during a statistics when we had stats and ops research, no? At that time, we did
Okay,
regression on R.
okay. So you know the basic, functioning, how to write the model on R, right?
So we did it manually and we even ran the LM model. That's how we did it actually.
Was it a simple linear regression or you did multiple linear regression?
I think simple only we had done so.
No, Ali, I think we did multiple too.
Okay, cool.
LM, and then when you have y tilde x, you can also add with a plus sign.
Okay, then maybe I missed that part.
Correct. Okay, all right. So what I'll do in today's lecture is I'll take up certain questions from Woolrich. I request if all of you have Woolrich on your laptop or any other device, you can open Woolrich chapter 3, and we'll take up some of the examples or exercises, and we'll try to solve certain questions on R. Now there are a couple of things. I don't know how many of you are familiar with writing or this writing this coding language on R. Uh, जो familiar है well and good. जो नहीं है I have time and again mentioned this book apply using R for use using R for econometrics. There's this book, and then if you'll ask me, I'll also give you the link of there are certain online sources available where you can learn the basics of R right from start. So in today's lecture, what we'll do is whatever we have discussed till now, OLS in matrix method, and some of the simple exercises of multiple linear regression that we'll perform using R. So just let me just see the question. Okay, one more thing. Why I asked you to solve computer exercises from Woolrich is because there are, automatically installed packages of Woolrich. So all the data set that Woolrich has used in his textbook, you just need to install the package Woolrich on R or RStudio, whichever interface you are using, and then you need not load the data set and read, import the data set and loading on R. So that step can be skipped. You simply go to I'll tell you the process. So all the data set that Woolrich has used in his textbook can actually be performed on R because they are automatically installed on R and RStudio. Now, basically, I prefer using RStudio. I'm sure that RStudio gives you the only advantage of using RStudio is that it also gives you a hint, where you're making mistake, and so it is easier to identify your mistakes while performing or writing these codes via RStudio rather than the raw version of R. But it depends completely on you, whichever you want to use. So let us take a very simple example, and we'll try to solve this question using matrix method and the normal LM function that we use for multiple linear regression. I'm talking about example 3.1 that is given in chapter 3 of Woolrich. Uh, so if you could see that example once, and then I'll start. Or should I present that example on my screen?
Yes, sir.
Okay, all right. Can you all see the screen now?
Yes, sir, it's visible.
Yeah, right. Give me a second. Okay, all right. So this is a very simple example. Actually, the data set, if you see the data set GPA1, it contains lot many variables. But for the sake of simplicity, here the example only talks about two explanatory variable and one response variable, that is our college GPA. So basically, it talks about regressing college grade point average of various students, and the sample size here is 141. So basically they have interviewed or they have collected scores of high school GPA and sorry, an achievement test score for 141 students, and they're trying to fit a regression, or they're trying to build a model where they want to understand how the achievement score or achievement test score and high school GPA affects performance of these students in the college. Just give me a second. Yeah. So if you actually see, this is the estimated equation that they've come up with. So अगर आप actually इसको implicit function की form में लिखना चाहो तो this is your y hat beta 1, or let me write in hat form, beta 1 hat plus beta 2 hat x1 plus beta 3 hat x2. And there is no error term because this is the estimated value. So the population regression function in this case, you simply write y beta 1 plus beta 2 x1 plus beta 2, sorry, beta 3 x2 plus y. And then we try to estimate these beta 1, beta 2, beta 3. So here they've already estimated this 1.29, 0.453, and 0.0094. So these are the estimated coefficients that they have obtained. We'll solve this using R and C, from both the methods. OLS जो हमने देखा matrix method में x transpose x inverse x transpose y जो करते हैं. So we'll try to solve that and we'll calculate all the variances as well. So let me begin. Just give me a second. Okay, can you all see the screen now? Our studio screen.
Yes, sir.
Okay, all right. Just for my own practice, I have done this, but I'll start I solve this entire exercise here. Okay, all right. Just give me a second. So जो first चीज आपको करना है वो है इंस्टॉल आपको करना है पैकेज बुलरिज को that I have already installed, but I'm just writing these steps so that no. So install dot packages Woolrich. So if I, as I'm really sorry. So if you run this command over here, which I've already installed, but this tells me that this package has already been installed. So first thing that you have to do is you have to install this package, uh, which is the package name is Woolrich. So I already have the package, so I need not run this command again. Next thing that I have to do is I have to get the data GPA. So what I do here is data GPA1. And you see the advantage of using R Studio because it gives you the argument as well, so that the chances of making errors are minimized. And anyway, when you go in the corporate, they normally use R Studio only. So this is the data that I have. So if you just want to see the first few rows of your data, so you simply have the head function. So you see, there are so many variables. There are multiple number of variables in this GPA data set. But if you see the example, they have only talked about this portion: college grade point average, high school grade point average, and achievement test score. So precisely, we want to extract this part of this entire data set. So what I do is, just a second, guys. Yeah. So I have to get this, like, this is my dependent variable, college grade point average, and I want to run a model which establishes a relationship between college grade point average and achievement test score. So what I do is
So you're not audible.
am I audible now?
Yes, sir.
Yes, sir. Now you're audible.
Okay, I'm really sorry. There are some issues. Yeah. So let me just go here. Something. So I performed this command. That is, I got the data GPA1 package Woolrich. Next thing that I have to do is I have to define the number of rows. So there are 141 observations, so number of rows remains same. So that becomes my n. So n, I have given the variable n rows as n. So n row GPA, that is number of rows in GPA1 becomes my total number of observations. And how many number of independent variables I need only this much: high school GPA and achievement test score. So I have assigned a value of k. In this case, k represents your independent variable or explanative variable. So k takes a value 2. So this here defines my data dimension of the data matrix. So I have 141 observations and the two number of explanative variables excluding the intercept, which is properly understood over here, that once we have the data matrix, I need to have the column of ones which is there for the intercept term. So next, I have to, you know, make this college grade point average as my dependent variable. That is y. So that's what I have assigned. Y will be GPA1. That is the data set, and which column I particularly want. So I want this call GPA, and so I'm assigning college grade point average to be my dependent variable. That's why this dollar sign comes over here. That is, out of this data set, it is this college grade point average which you actually want as your dependent variable. So this is how you assign variables, guys. These are the steps that I'm skipping because I'll assume that you know how to assign variables and what are variables, what are vectors, as far as R is concerned. और थोड़ा सा भी अगर प्रॉब्लम होता है you can easily get multiple sources which explains how write variables on R. So that's why I'm not explaining all this, but this is how you assign. You can also write equal to it. It does not matter. Now, मेरा dimension of the data matrix excluding intercept तो तैयार है 141 rows and k, that is two number of explanative variables. But since I'm running a model, running a population regression function model where intercept is assumed to exist. So far we have not discussed at all about regression through origin, which we'll discuss in future lectures. But जब तक आपको ये बोला ना जाए कि जो आपको रिग्रेशन रन करना है या पॉपुलेशन रिग्रेशन फंक्शन जो आपने अज्यूम किया है वो विदाउट कांस्टेंट और विदाउट इंटरसेप्ट टर्म है, तब तक आप अज्यूम करके चलते हो दैट माय पॉपुलेशन रिग्रेशन फंक्शन कंटेन्स एन इंटरसेप्ट टर्म. I'll tell you the reasoning logic behind it, because almost all your statistic, one of the most important statistic, that is your R square, depends on the assumption of constant term there in the population regression function. And you can verify this argument by looking at the formula of R square, which includes TSS, and explain sum of squares contains that you calculate explain sum of squares assuming there is an intercept term. So when intercept term is not there, your usual method of reporting R square goes for a toss. Your R square might also come out sometimes as negative, which we'll discuss all this. When what happens when you run a regression without an intercept term or regression through origin. So जब तक ये explicitly mention नहीं है कहीं पे भी, you always assume intercept term to be existing. That's what the fundamental point that we have to understand here. So now मेरा data matrix कैसा चाहिए, ये तो दो मुझे मिल गया है, ये 141 observations on these two explanative variables, but I need one extra column, and that column is there for the intercept term. It means apart from these two column vectors, I need an additional column vector consisting of ones for the intercept term. And that's why I've used this function cbind, which is column bind, or there are bind function as well, row bind function. So what this function does is it combines two vectors column wise. So or it combines column vectors together. So I have defined my data matrix X as cbind, that is cbind is a function. The first vector or the column vector is column vector consisting of 1. The second column I want is the high school GPA from the data set GPA1. That's why I've written GPA1 $sign HSGPA. And then the third column that I need is the achievement test score from the data set GPA1. So GPA1 $ACT.
Sir,
Yeah.
sir, could you please increase the size of this console?
Oh, yeah. I'm really sorry.
Thank you,
अब दिख
sir.
रहा है?
Yes, sir. पहले से
Yes,
थोड़ा
sir. Thank you, sir.
और इसको zoom करूं क्या? Let me just.
सर font size अगर बढ़ सकता है तो बढ़िया रहेगा.
सर आई थिंक वो टूल्स में होता है, टूल्स, ग्लोबल टूल्स,
Global options.
अपीयरेंस.
Okay, all right. अभी दिख रहा है अच्छे से?
Yes, sir. Thank you, sir.
This is my data matrix now. Let me use the pen if I can. Yeah. So this is my data matrix now, which is defined as X. So X को मैंने कैसे combine किया है? I have combined the vector of ones with the column vector consisting of high school GPA and achievement test score. So this is my data matrix now. So, if you have to look at this data matrix, you simply again call the head function. Head function gives you first initial 6 rows of the data set that you have. You can also use tail function. So tail function to look at the last 6 observations of the data matrix. So calling the head function will give me, the first 6 observations. So this is the column consisting of 1. This is the 6 number of observations on high school GPA obtained by students, and this is the 6 observations on achievement test score by the students. और इस तरह करके मेरे पास 141 अब जो मेरा data matrix का dimension होगा, if you have to check the dimension of the data matrix, you simply call the function dim. So dimx will give you the dimension of this data matrix, and that dimension will be 141 by 3. That is 141 number of observations and 3 number of independent variables or explanatory variables, including the constant. Now, so this is my data matrix that already I have prepared. Now, you see, सबसे ब्यूटीफुल पॉइंट आर का यही है कि अगर आपको फॉर्मूला अच्छे से पता है या जो भी स्टैटिस्टिक आप यूज कर रहे हो, अगर आपको उसका फॉर्मूला पता है, यू कैन राइट द फॉर्मूला एग्जैक्टली एज इट इज ऑन आर. And that's why our using R for econometrics purpose you know, is very useful, because you can write your own function as long as you know the formula. Now you see here, I have done nothing. I have simply written the formula for the estimators, OLS estimator, which is X transpose X ka inverse X transpose Y. Are you with me here?
Yes, sir.
Yeah.
So
Yes,
what
sir.
does the percentage sign do?
Percentage sign is for the multiplication here, multiplication of matrices or vectors here पे नहीं.
All right, all right.
है ना? So for vector multiplication or matrix multiplication, we use this percentage, this whole sign. So OLS estimator का क्या है मेरा formula? I know that formula is X transpose X inverse X transpose Y. So just look at this part first. This Tx is X transpose, that is transpose of X. So Tx is your X transpose. And now this is matrix multiplication. That's why I've used this percentage, percentage cross percentage. So this is for the matrix multiplication point. So X transpose X. Now this solve is used for finding inverse of a matrix. Okay?
So solve is only used for matrices, or can it be used for other things as well? General question.
Come again?
This solve, what you've written, is it only used to multiply, to find the inverse of a matrix, or can it be used for other things as well?
No, solve is a function on R which gives you the inverse of a matrix. So it's a function which is specifically for finding inversion of a matrix.
Okay, sure, sir.
ठीक है? So ये जो part है मेरा, X transpose X का inverse is my solve. Solve X transpose X will give me X transpose X inverse. Now this again entire matrix gets multiplied with X transpose Y. So X transpose के लिए I have written T of X, that is transpose of X. Again multiplied is given by this symbol by Y. Y here is my dependent variable. So I have simply used the formula. That's what we have been studying till now. So B hat, that is your estimators, is obtained by X transpose X inverse X transpose Y. Is this clear?
Sir, could you just repeat it once again?
Yeah, yeah. What is my B hat? What is the OLS estimator formula? हमने क्या देखा था, dear? That was X transpose X inverse X transpose Y, right?
Yes, sir.
आपके पास ये X है, so आपने इसका पहले ट्रांसपोज किया, that is written by T of X, so you have transposed this, so T of X is X transpose. Now this gets multiplied by X, so that's why I have used this symbol. This is a function which perform the operation of multiplication of matrices or vector. And is X transpose X का total का inverse will be given by solve function. So solve T of X multiplication symbol X will give me X transpose X inverse. Now this gets multiplied by X transpose Y. So first I've written here X transpose, that is T of X X transpose multiplied by Y. So this is X transpose Y. Now X transpose X inverse is this part, X transpose Y is this part. This gets multiplied and that's how you get your beta hat. That is your OLS estimators. Is this clear?
Yes,
Yes,
sir,
sir.
it is clear.
All of you? हमने कुछ नहीं किया है, हमने
Yes, sir, it's
सिंपल
clear.
फॉर्मूला जो हम अभी तक जो पढ़ते आ रहे हैं, जो भी हमने डिराइव किया था पेन पेपर पे, उसको हमने सिंपल यहाँ कोड में लिखा है. So we need not do it manually. That's what software helps us out. Is that clear?
Sir, clear, sir.
हाँ जी.
But there's a lot easier way of handling this.
हाँ बोलो.
There's a whole function called LM function, which is inbuilt into R that helps find the coefficients.
नहीं नहीं, LM function is there for the regression estimates, right? वो एक पूरा function है. That's what we'll do. But solving OLS using matrices method, जो भी हमने किया है अभी तक, उसको हम सिर्फ एग्जांपल से देख रहे हैं.
Yes, sir. Yes, sir.
Nothing else. So जब LM फंक्शन यूज करते हो, वो आपका सीधे रिग्रेशन एस्टिमेटर से कोएफिशिएंट स्टैंडर्ड सब कुछ देता है. देयर इज नो डिनाइंग दैट. ऑल आई एम सेइंग इज जो भी हमने पेन पेपर पे किया अभी, दैट कैन इजीली बी डन यूजिंग आर विदाउट एनी मैनुअल कैलकुलेशन. नथिंग एल्स. ठीक है. Shall I go ahead?
Yes.
Yes, sir.
Okay, all right. So these are your coefficients, your intercept coefficient हो गया, और ये these are the two slope coefficient estimators that we have got. So this is your beta 1 hat, beta 2 hat, beta 3 hat. The way you have mentioned, whether it's beta not beta 1, beta 2, it does not matter. Now next thing that we do is we calculate the residuals. That is, and residuals again I have just used formula. Formula is y minus
Sir, we can't hear you.
can you hear me now?
Yes, sir.
Yeah. So this u hat, अगर आप actually देखो pen and paper पे u hat हमने कैसे निकाला था? That is residuals is e is y minus x b. y मेरे पास है already, x मुझे पता है, beta अभी हमने just निकाला, that is beta hat. You can easily calculate this u hat, and so it will be a column vector consisting of all those 141 observations on your all the residuals. So yeah. Now next thing that we have done is, in order to talk about variances and covariances of the OLS estimators, if you go back, remember the formula, it comes out as sigma square x transpose x inverse. So x transpose x inverse तो मुझे easily पता है. Sigma square is the variance of the population error, which is mostly what we do not know. So we had talked about it that an unbiased estimator of unknown population or unknown variance of the population error is nothing but your RSS upon the number of degrees of freedom, that is n minus k minus 1. Now, U hat मुझे पता है. RSS is, I know that, summation, UI square, and that can be easily obtained by pre-multiplying U hat with its transpose. So if you see, I have done the same thing over here. I have got transpose of U hat, that is U transpose, again multiplied by U hat. So this numerator gives me the RSS divided by degree of freedom, in this case n minus k minus 1. So this gives me an unbiased estimator of the sigma square. And why do I need this sigma square? Because in order to talk about the variances of or variance covariance matrix of the OLS estimators, I need sigma square. Since I do not know the true sigma square, I obtain an unbiased estimator of this unknown sigma square, which is given by RSS upon degree of freedom. So this comes out as whatever value 0.11. Now, if you see here, we have talked about variances of the OLS estimator. So variance of OLS estimator is nothing but, again, sigma square, which is this SIGS hat, multiplied by X transpose X inverse. Again, same thing, sigma 6 hat, this is the variable that I've assigned to this formula, multiplied by X transpose X. So this gives me variance covariance matrix of this OLS estimator. Now, we have already discussed this part that the diagonal elements in this case will give me the variance of beta 1, beta 2, beta 3, and all these other off diagonal elements are the covariances. So this is your covariance of beta 1 with beta 2, beta 1 with beta 3. And since this variance covariance matrix of the OLS estimator is square and symmetric, so जो ये वैल्यू होगा, जो ये वैल्यू होगा, वही यहाँ पे भी वैल्यूज होंगे. जो ये वैल्यू होगा, वही यहाँ पे भी वैल्यूज होगा. No, the entire purpose of solving this exercise using this is that whatever we have done till now using matrices method, that can be easily solved without having any manual calculation on our Excel पे भी आप same चीज कर सकते हो. Now, next thing that we do is we take the same exercise or let's say other exercise, and that's where we use the formula which is your OLS regression formula, that is commonly known as LM formula. Now, before we solve for LM formula, or before we discuss the formulas that are used to talk about multiple linear regression on R, one thing that you have to understand is when you run a simple linear regression, you simply have an independent variable and a dependent variable. So simply write the formula LM by the tilde sign and the independent variables. So in case of simple linear regression model, just give me a second. So in case of a simple linear regression model, you need not worry about how do I actually account for the additional variables when it actually needs to be included in the model. Taking this case forward, when you have more than one number of independent variables, what you face generally is called as multiple linear regression model. So multiple linear regression model is a term which is reserved for the case when you have more than one independent variable and one single response variables. When we go ahead in our courses, not probably in basic econometrics, but when you go in advanced econometrics, that's where you talk about multivariate regression models. Multivariate is when you have more than one response variable. That's where you talk about vector auto regression and so on and so forth, because now you have more than one response variables apart from more than one independent variable. So in order to account for these multiple linear regression model, we simply take the LM formula
So you're not
We
audible.
can't hear.
Can you hear me now?
Yes, sir.
Yeah. Second. So when you talk about multiple linear regression model, the only addition that we do as far as writing code on R is concerned is we call the LM function, which is there for the linear regression. And since we are talking multiple linear regression, I only need to worry about one response variable. So LMY, y is my dependent variable, that tilde sign. And the way you write your population regression function, in the same manner you write the code as well. So LMY tilde x1 plus x2 plus x3 and so on and so forth. Why do we write this in this manner? Because we assume, or the function LM gives us a linear regression function, and linearity in this sense that parameters are linear in nature, and that's why you simply write the way your population regression functions are there. Now इसी में थोड़ा अगर मान लो, if you're talking about polynomial regression equation, that is y is equal to beta naught plus beta 1 x plus beta 1 x square. Again, nothing you have to do. Again, I write x1 plus x2. अगर x3 का square है या x2 का square है, then plus x2 whole bracket उसका square. So this is how we actually go for writing codes as far as regression models are concerned on R. Now we'll take one example and we'll solve that using R here. And we'll try to interpret the results that we get. That's what we discuss about the p-value and the various statistic that we have discussed so far on pen and paper. Just give me a second. Let me take that example.
Sir, actually, I have one question.
Ajay.
I understood everything, but like I installed the Woolwich package, but I am not getting the data. Can you just show me the code? Like I understood all the process of everything, but I'm not
Yeah.
getting the data. Like, I installed the Woolwich package, but can you
Install के
show
बाद
the
आपको library, you have to call the library function there. After you install the packages, let me just show you. So after I install my package, then you have to call that function. After that, you can start using all the data sets that are there in the package knowledge. Is that clear?
okay, sir. So okay, got it.
हाँ, तो आपको install पहले करना है, उसके बाद आपको library से उसको call करना है. So installation is just required once, but whenever you want to use the package, you have to call it from the library.
Okay,
Is
sir.
that clear?
Okay, sir.
Okay, all right.
Sir,
हाँ जी,
so what was the code for you had?
क्या बोल रहे हो dear?
Sir, what was the code for you had?
You had
वाला,
आप
sir.
कैसे लिखते हो? पहले आप पेन पेपर पे लिखो. You had क्या है आपका? Residuals?
Yes, sir.
Residuals आप कैसे लिखते हो? Tell me that.
Sir, RSS I guess उससे calculate होते ना?
RSS बाद में आएगा ना भाई. Residuals क्या होता है ये पहले बताओ.
Sir,
How do you write
unexplained
the
things in
population
the
regression function?
y equal to sir beta 1 plus beta 2 x plus mu.
Correct. अब इसका आप सैंपल वर्जन कैसे लिखते हो? Y is equal to b1 plus beta 2x plus ei, right?
EI,
Or e,
yes,
whatever,
sir.
right? तो जो आपका e है वही तो रेसिडुअल है ना?
Yes, sir.
उस e को आप कैसे लिखते हो? Y minus beta 1 minus beta 2x,
Yes, sir.
है ना? जो आप राइट हैंड साइड का एक्सप्रेशन आप उस सिंपल लेफ्ट हैंड साइड पे लेके जाते हो, वही आपका e हो जाता है. दैट इज योर रेसिडुअल.
Yeah, yes, sir.
अब उसको मैट्रिक्स मेथड में कैसे लिखोगे? E is nothing but y, that is column vector consisting of n number of observations on dependent variable minus of beta times x or x beta.
Yes, sir.
है ना? तो y आपका है तो द कोड कैसे जाएगा फिर मेरा y माइनस x मल्टीप्लीकेशन साइन एंड दैट बीटा हैट.
Okay. Yes, sir. Got it now.
इज दैट क्लियर?
Yes, sir.
सो जो फॉर्मूला है वही वैसे ही होगा एंड देयर इज नो डिफरेंस बिटवीन दैट. जस्ट लेट मी टेक दैट एग्जांपल वंस. Okay, all right. So let us. Can you see the Woolwich textbook on my screen?
No, sir.
All see now the screen.
So you're not sharing your screen right now?
Yeah, can you all see that now?
Yes, sir. It's visible.
Yes, sir.
Okay, all right. So let us take this example, which is about explaining arrest records in California. So there's this data set called Crime One, which contains data on arrests during the year 1986 and other information on 2725 men born in either 1960 or 1961. So this is what the entire model is. There's this linear model which has been run, so and which tries to explain or which tries to have a relationship between number of times the man was arrested during 1986. So this becomes my explained variable or dependent variable in this case. And all this PCNV stands for yeah, proportion of arrests prior to 1986, that is percentage of conviction, average sentence in prison, that is average sentence length, prison time in 1986, and quarter of employment, I guess, number of quarters during which the man was employed in 1986. So here there is a linear model which tries to explain a relationship between the number of times a man gets arrested during the year 1986, and it depends on what is his prior conviction or whether he was arrested prior to 1986 as well that led to his conviction. That is my first independent variable. What was the average sentence length that he served for the prior convictions? What is the time spent in the prison? And the number of quarters during which the person was employed in the year 1986. So this is the population regression function that they have written. And what this, first of all, before we talk about writing a code for this, what this tells us is that in order to understand the number of times a man gets arrested in this particular year depends on these four parameters. Is he a repeat? One second. Is he a repeat offender? That is, was he arrested and convicted prior to this year? If so, what is the average sentence length that is served for prior convictions? And then in the current year, and the number of quarters during which the man actually found employment. इस सब का एक लिटरेचर होगा, इस सब का एक रीजनिंग होगा कि अगर एक पर्सन बार बार अरेस्ट हो रहा है इस ईयर में, if he was earning or if he had some income which is related to legal activities, there is less and less incentive for that person to indulge in criminal activities. If he's a repeated offender, that is, he has been convicted and arrested for prior felonies that he has committed, the impact of the actual cost or the impact of imprisonment on the person, whether that actually is successful, that is, if the person undergoes a severe punishment, does he again fall back to indulge in criminal activities or not? This is why this average sentence as an independent variable has been included, which is also called as recidivism rate. No, because there are various theories of crime. One of the theories which says that if you increase the probability of conviction and severity of punishment, the probability of a person falling back to criminal activities gets lesser and lesser, and that's why this entire narrative or this entire model tells you about. So again, we'll go back to the data set. We have this four number of independent variables, one dependent variable. So my regression function will look like lm y. Automatically, when you write, you need not write intercept term ka code alag se, because it is automatically assumed that you are running a regression through intercept. When you do not have an intercept term, then we have to write that specifically. So it will be simply, y here will be this variable NARR86, that is number of times arrested, PCNV plus average sentence plus present time plus Q employment. This simple function will give me the entire regression estimates. That's what our main aim would be. So let me go back to the R Studio and let you see how do we actually do this. One second. Yeah, can you all see the screen now? या अब मुझे क्या चाहिए, मेरे पास ऑलरेडी पैकेज है ये crime 1 and package is Yeah. So now it has loaded the data set, which is my crime. अब मुझे क्या चाहिए? I have to run this regression, which where my dependent variable is. So let me see the head of crime first. So this is how the data set looks like. You have these are the number of variables that I have. So in this case, this becomes my dependent variable NARR86, PCNV, average sentence, present time, and quarter employment. These are the four variables that I have to run a regression model. So let me write as I assign the variable model LM. Now I have the dependent variable as NARR86, follows by tilde sign, which is your which separates the independent variables from the dependent variables. And then simply the way we write the P time 86 plus Q employment 86.
So the data set is crime one.
Oh,
which is
sorry, yeah. Data
called.
set. I'm really sorry, yeah. Yeah. Now, if we write model, yeah, and if I have to just see the summary, I'll simply say summary model. Yeah. So, yeah, so this is my model. That is, I have run a regression of number of times arrested. A man was arrested in the 86. These are the four number of independent variables that I have used from that, and I forgot to mention the data set in the first time. That's why it says the object was not found, because it does not recognize actually which data I'm talking about. So this part was necessary. So I have run this regression from the data set, which is crime one. This data set was loaded from the package Woolrich. That's how it comes. So this is the coefficients. That is intercept coefficient is 0.706756, and these are the beta 1, beta 2, beta 3, beta 4, if you talk about this as beta naught. Now, yeah. Now, summary of this model gives me, if you actually see, this is the main part which we are concerned about. This is the main part which we have to interpret as far as, questions on regression, or, if you see any table, they are basically the results are represented for a particular regression equation that the researcher or the author has run. So this is the main part that we have to understand. Some of the terms are self-explanatory, and some of the terms we have already discussed, but we'll discuss them, that what actually they mean here. So intercept, that is here in this case I have 5 number of independent variables including the constant. So the first column here is intercept. The first column consists of those estimators. So intercept, first independent variable, second, third, and fourth. And this is the value of the estimates that we have got from the OLS method. अब ये standard error है associated with each of these variables. So standard error of intercept term is this 0.03, standard error of PCMV is this 0.04, and so on and so forth. अगर आप याद करोगे हमारे discussion of hypothesis testing में, तो हमने hypothesis testing में क्या discuss किया था कि when you run a test of significance, that is when you go for testing a hypothesis where you are actually testing whether a coefficient is statistically significant or not. In that case, the statistic, that is T statistic, which is actually written as the value minus the mean of that value divided by standard error of any statistic that you talk about. And since we are talking about a null hypothesis which assumes the coefficient to be having a value 0, that's why we can simply calculate the T statistic of the coefficient of the variable
Sir, you lost audio.
Can you hear me now?
Yes, sir. Now we can.
Okay. So where was I? Where did you
Yes.
lose? Where was I? कहाँ तक आपने सुना था? What was it discussing? Yeah.
So you were explaining a standard error.
Okay. All right. So जो T statistic है मेरा, वो T statistic in case of test of significance क्या होगा? The value of the coefficients divided by standard error, assuming your null hypothesis to be true. All of you remember this discussion?
Yes, sir.
ठीक है. So आप इसको verify करना that this estimate divided by standard error will be this T value. सबके लिए valid है. Now this is the probability of getting such a T value, assuming your null hypothesis to be true. This is a very, very important column, which for the time being I'll discuss it in few minutes time. But just understand that this column gives you the probability of this statistic, this T value. That is, how have you obtained this T value? You have obtained this T value assuming your null hypothesis to be true. So assuming the null hypothesis to be true, what is the probability of obtaining a T value having this particular value? Chalega ye point? Now these star signs are the significant codes, that is whether they are statistically significant at 99% or 95% or 90% or 85% or 80%. So this was these significant codes are there for, which is statistically also written as alpha. Now this residual standard error is given as 0.8414. Degree of freedom, you already know, you had number of observations as 2725. At 5 number of independent variables, including the constant. So you have total degrees of freedom left is 2720. This is a multiple R squared. This is your adjusted R squared. F statistic is 29.96 on 4 degree of freedom in numerator, which is your ESS, that is K minus 1, and denominator mein N minus K. That's why you have 2720 degree of freedom. And this P value is for this F statistic. And this P value, you can notice this is a very, very small value. So P value kya hai? Again, जो ये प्रोबेबिलिटी वैल्यू था इस टी स्टैटिस्टिक के लिए, वही ये पी वैल्यू यहाँ पे इस एफ स्टैटिस्टिक के लिए है. That is, assuming the null hypothesis to be true, the probability of obtaining a F statistic having the value 29.96 with degree of freedom 4 and 2720 is extremely small. Now, ये P value क्या है? And why P values are, now they are often reported as far as software results are concerned. So P value is called as probability value. Now, in pure layman terms, probability value or P value should be understood as it is the lowest value of the level of significance at which the null hypothesis is rejected. I'll repeat my sentence, but just understand this point. What P value talks about is, first, P value is a probability value. Probability value of what? Probability value of a given statistic. So जो हमने उस coefficients का T value along with the probability value देखा, वो उस T statistic का probability, that is P value था. हमने T statistic कैसे obtain किया? We obtained the T statistic assuming null hypothesis to be true. So P value gives you the probability of obtaining that statistic assuming the null hypothesis to be true. Up in other terms, how do we actually understand what P value is? So I'm sure while you would have the courses on statistics, you would have learned in the chapter hypothesis testing that whenever a researcher conducts a hypothesis, there are basically two types of errors that the researcher undertakes. They are typically called as type 1 and type 2 errors. Type 1 error is your probability of rejecting a null hypothesis when actually it was true, and the vice versa for type 2 error. Now, all this statistic which we calculate, and the decision rule is to compute the T statistic, compare that computed T statistic from the critical T statistic from the T table for particular values of levels of significance, that is, or alpha values. Now, this alpha value depends on the researcher. This level of significance is actually the amount of error that the researcher is willing to tolerate. So if you fix your alpha to be 0.01, that is, your confidence level should be 99%, it means that as a researcher, you're only willing to tolerate 1% of the errors in sampling. If you set your alpha to be 5%, it means as a researcher, you're willing to accept an error of 5%. So setting the value or setting the level of significance depends on the research. Your critical T statistic changes. इसी को to overcome this problem, because again, अब कोई researcher 99% रखना चाहेगा, अब कोई रिसर्चर 99% रखना चाहेगा, कोई रिसर्चर 95% रखना चाहेगा, कोई रिसर्चर 90% रखना चाहेगा. In order to overcome this problem, this P value has been, or this statistic or this probability of obtaining this statistic was designed. So P value का क्या significance है? P value is the lowest level of significance at which the null hypothesis is rejected. Now, a decision rule that will follow over here is that if your P value, if the probability value of obtaining a T statistic or F statistic or a Z statistic is less than the level of significance which you actually chose, So suppose as a researcher you chose the alpha to be 5%, but p-value comes out as 3%. So what it means that the statistic that you have obtained for this particular question gets rejected at 3% only, but you had chosen 5% level of significance. So decision rule is that whenever the p-value is less than the alpha, you reject the null hypothesis. And vice versa, when p-value is greater than alpha, it means जो भी आपने level of significance actually choose किया था, उससे कहीं ज्यादा उसका probability है आने का. So if your p-value is greater than the level of significance, you do not reject the null hypothesis. So p-value is the lowest level of significance at which your null hypothesis is rejected. एक और तरह से इसको आपको समझना है, तो lower the p-value, greater is the chance of rejection of the null hypothesis. का logic क्या है? वो जो p-value है, वो है उस statistic के आने का. Now, that statistic, or you have computed the value of that test statistic, assuming the null hypothesis to be true. And if the probability of obtaining that statistic itself is very small, very low, it means your null hypothesis is not true, and that's why you reject the null hypothesis. So p-value is a very, very important parameter as far as results of regression are concerned. Very often they are asked in interviews, what exactly is a p-value? So you have to first define a p-value to be understood in terms of a probability value. Probability of what? Probability of obtaining that statistic which I'm talking about. And now the decision rule is, or the layman term, just just to understand this term, एक rule है कि जितना कम होगा p-value, lower the p-value, higher is the chance of rejection of the null hypothesis. Am I clear about p-values? Guys, am I clear about p-value?
Yes, sir.
Yes, sir.
कोई problem नहीं, but p-value बहुत ही it is a question which gets asked a lot by the interviewers. Also, जब आप regression results को interpret करते हो तो p-value बहुत ही काम में आता है, because p-value को आप simply देख के you can easily make a decision whether the hypothesis should be accepted or should not be rejected or be rejected. Okay, I'll stop here because I have a running nose and I'm not feeling that well. In tomorrow's lecture, I'll again take up one or two examples or computer exercises, or I see if there are any exercises available online which can be discussed. I'll do that. So go back and revise what we have done. At least जो भी example है Woolrich के, वो आप सारे at least R में एक बार उसको solve करके देखो. जितने भी example, right from chapter 2 till chapter 3, or even if chapter 4 you can do, that will work. So start from simple linear regression model, write a code for that, and then move to multiple linear regression model. The steps are, generally use RStudio because that will be helpful in order to identify the mistakes. Steps क्या है? आप install.packages से Woolrich package आप install करो. Then you call the library function. Calling is required every time you use that function, but installing only once. And then you can simply load the data set. अगर if you do not want to do this exercise, let's say if you have some sort of Excel exercises on your laptop, on your desktop, or whatever device that you're using, and you want to import that data set into R itself, again, it's a very
Sorry, lost audio again.
Can you hear me now?
Yes, now we can hear you. The last thing we heard was it is a very, and then it cut off.
Okay. So what I mainly want to talk about here is that जितने भी एक्सरसाइजेज हैं वुलरिज के, वो अगर आप सपोज नहीं करना चाहते हो, and let's say you have some sort of data set on your laptop, on your desktop, so there are various there are codes which through which you can load your own data set, you can perform your own regression exercises so that you get more and more confidence. So आप कोई भी एक्सेल फाइल उठाओ या आपके पास कोई अगर एक्सेल फाइल है, you load that data set into R, mostly in the read .csv file. So simply you set your working directory and then you mention the file name, and that's how you import the data set or load the data set into R. पर जो भी हमने अभी देखा R स्टूडियो में, वो बहुत ही इजी होता है. आप सिंपली इंस्टॉल और पैकेज करोगे, वोल्टेज का सारा डेटा सेट आपके पास होगा. And if you want to play with any of the data set, you can simply call that data, mention the package name Woolrich, and you can perform any exercise that you want. So that's up to you. But please, at least solve these examples from chapter 2 and chapter 3 on our install.package karo, library function se ek baar usko call karo, and then start manipulating these data, start interpreting these results. आप कोएफिशिएंट्स को पहचानना सीखो, कोएफिशिएंट कैसे इंटरप्रेट करते हैं, रिग्रेशन रिजल्ट्स को कैसे इंटरप्रेट करते हैं. Sometimes you simply try to find out कि अगर क्या मेरा जो रिग्रेशन एस्टिमेट्स है या ओएलएस एस्टिमेटर्स है, क्या ये डिपेंड करता है यूनिट्स ऑफ मेजरमेंट पे. That is, if some values are written in thousands, and if the other researcher expresses that value in hundreds, does that impact my OLS estimates or value of OLS estimates? So such kind of exercises, though you definitely find them in textbook, but जब आप उसको खुद से perform करोगे तो वो आपके memory में हमेशा रहेगा. And that's why that is more important that you perform these exercises using such examples. In tomorrow's lecture, again, I'll take a few examples and we'll try to solve them. And then I discuss about dummy variables in brief, because I have not discussed about dummy variables as such. And after that, we'll start with violations of assumptions of CLRM. And the first violation that we talk about is the violation of spherical disturbances. That is, we'll talk about heteroscedasticity in detail. Autocorrelation we'll study, but we'll not study much, because when we introduce time series, we discuss the violation of autocorrelation there. Sorry, presence of autocorrelation, violence of non-autocorrelation. So basically, we'll discuss multicollinearity, homoscedasticity, and non-autocorrelation ke violations. And we'll talk about the remedial measures, and then we proceed towards model check, that is model diagnostics. So अगर आपको whatever model अभी तक हमने simple model run करना, model के results को interpret करना सीखा है, but it does not guarantee that the model that we run is the best and correct model. So that's where we understand the model diagnostics or diagnostic checks, where we perform various tests to check whether the model that we have run accurately fits the data or not. So we put a trial and error method, but we'll discuss that part after we discuss the violations, and that's how it will make more sense. So in tomorrow's lecture, I'll take up one or two examples, and then we discuss about dummy variables. In brief, yeah.
Yes, sir. So hypothesis part वाला जो क्वेश्चन दिया था सर आपने, कंपाउंड हाइपोथेसिस सर वो लाइक आई ट्राइड बट हो नहीं रहा मेरे से, तो क्या सर उस पर थोड़ा सा टाइम?
तो एक काम करना, whatever you have tried, you just mail me or send a screenshot of that, और जहाँ भी problem I'll identify and get back to you.
Okay. And one more thing, sir, वो yes sir. सर वन मोर थिंग दैट हम कोई ऐसा रियल लाइफ काइंड ऑफ एग्जांपल ले सकते हैं कंपाउंड हाइपोथेसिस का?
बहुत सारे एग्जांपल्स हैं भाई. सबसे पहला एग्जांपल ही तुम्हारा एफ टेस्ट है, अनोवा टेस्टिंग. जो भी मॉडल हम रन करते हैं, या मान लो आप कोई भी एक रिग्रेशन मॉडल लो, उस पे आप run a compound hypothesis is nothing but combination of simple hypothesis at one time. So मेरा एक hypothesis है कि beta 1 is equal to 0, second hypothesis उसी मॉडल में beta 2 plus beta 3 is equal to 1. Any example can be there, and the best example is always about the ANOVA testing that we do. ANOVA मॉडल जो होता है, जब आप रन करते हो कोई भी रिग्रेशन मॉडल, उसमें आप ANOVA टेस्टिंग भी करते हो. दैट इज एनालिसिस ऑफ वेरिएंस टेस्टिंग, वेयर यू चेक कि क्या जो भी मैंने मॉडल रन किया उसमें एटलीस्ट एक भी ऐसा इंडिपेंडेंट वेरिएबल है जो कि स्टैटिस्टिकली सिग्निफिकेंट है. तो वो एक एग्जांपल है कंपाउंड हाइपोथेसिस. कंपाउंड हाइपोथेसिस क्यों एग्जांपल? क्योंकि एट द सेम टाइम वो कॉम्बिनेशन ऑफ, अगर आपके पास 5 नंबर ऑफ इंडिपेंडेंट वेरिएबल्स है एक्सक्लूडिंग द कांस्टेंट, तो अगर वो सिंपल हाइपोथेसिस होता तो सिंपली होता बीटा 1 इज इक्वल टू 0 एक बार, beta 2 equals 0, beta 3 equals 0. But compound hai, it means that at the same time, all these coefficients are going to equal to 0. And that's how you write your null hypothesis. You write your null hypothesis, beta 1 is equal to 2, beta 2 is equal to beta 3 is equal to beta 4 is equal to beta 5 is equal to 0. And that's the example of a compound hypothesis. That is combination of multiple simple hypotheses at one time. एक तो ये है. Second, if you just look at any online exercises, अगर तुम्हें लगता है कि या check any textbook, statistics textbook or econometrics textbook जहाँ पे hypothesis testing chapter है, you'll find several questions on compound hypothesis. आपको जॉन्स्टन में ही मिल जाएगा एक दो क्वेश्चन उस पे.
Sir,
हाँ जी.
sir, can you please share the codes for this sums, the examples you have taken, sir?
Which course there? ये recording है already. I'll share the recording. That's what you want?
Sir, codes भी चलेंगे, sir.
Codes?
Yes, sir.
Okay, ठीक है, ठीक है.
Thank you, sir.
हाँ, हाँ, okay.
Thank you, sir.
But I'll encourage again you write your codes on, क्योंकि फिर उससे क्या होगा कि तुम खुद सीखोगे नहीं. तो just trial and error. Otherwise, send the codes. There is no issue for that.
Okay, sir. Thank you.
सर
हाँ जी.
एक छोटा सा क्वेरी, ये कंपाउंड हाइपोथेसिस एंड कंपोजिट हाइपोथेसिस सेम होता है सर?
Yeah, mostly yes.
Okay, thank you.
Okay, one last thing that I wanted to highlight here is जितना भी MCQs था, they all are previous year papers or asked in Delhi School of Economics papers. So those of you who found it really easy, so those are some of the recent econometrics questions that have been asked in these entrance examination. And I'm really happy that if you found it easy and not difficult to answer such questions. So और भी अगर थोड़ा कॉन्फिडेंस लाना है तो you can solve previous year question papers of econometrics from the year 2007 onwards, because of late they have been asking really easy questions in the AC papers. So 2007-6 onwards you can find जितना भी अभी तक हमने cover किया है till assumptions and all, you can find such questions. They are easily available online, and just try solving those MCQs, and that will give you really huge confidence moving ahead. So yeah, so that's what I wanted to tell you. So I'll wind up the lecture now. Tomorrow when we meet, please at least कुछ exercise आप खुद practice करके आना, so that जब हम discuss करेंगे तो आप और भी आपको ज़्यादा अच्छे समझ में आए, and we'll talk